All right, boys and girls, welcome back to the drive-through for a nice, calm little 6-bell quiet edition. Okay, this is trig identities. I don't know, I think we're going to call this 5.1 instead of 14.1. I've changed my mind on that. And full disclosure, this is part of the mathematical process that I hate the most. Honestly, I hate this section. So some things you should be aware of. One, we're all going to do our best. Two, at the end, your summative assessment for this is a game show. We will do game shows 10 people at a time. And if you choose not to do the game show, then we will I will also make a test for you to take if you prefer to take the test. The game show is just going to be a proof race, 5-on-5, 2 teams in front of the Cinemation Lab. So I think it could be kind of fun. Welcome back to logical proofs, but they're not the same because now these proofs have equal signs. To get you started, you need to know some, I guess, some pretty basic trig identities. So the cosecant of theta, just remember that that's 1 divided by the sine of theta. The secant of theta is 1 divided by the cosine of theta. The tangent of theta, well, that's 1 divided by the cotangent of theta. You could also consider that to be the sine of theta divided by the cosine of theta. Okay? And then similarly, I'm not going to write all these out, but the sine of theta is equal to 1 divided by the cosecant of theta. Busonic. Greatest technology of the 90s. Okay. So you also know that cosine of theta is 1 over secant, and cotangent of theta is 1 over... We should probably include that. The cotangent of theta is the cosine of theta divided by the sine of theta. Okay? In general, what you're trying to do in these is verify that the identities from one side are equal to the identities from the other side, or that the expressions from one side are equal to the expressions from the other side. In general, you want to start with the more complicated side and work step by step until it's the same as the less complicated side. Before we get going at this, you got to be good at fractions to do this section, and that's going to be a big issue. I think I've done my best to avoid fractions with you guys for the last 4 years, and now we don't really have any way around it. So let's do a quick little review. What's 1/4 plus 2/4? 3/4. Very good. So what did we learn from that? When we add fractions, we need a common denominator. And you don't add the denominators, you only add the numerators. Okay? What's 1/4 plus 1/5? We can't do that. So we're going to multiply this one. What's the only thing we're allowed multiplying by, Carson? It doesn't change the outcome of a number. We're only allowed multiplying by 1. So I'm going to multiply that one by 5 over 5. What's 5 over 5?
1.
Am I allowed to multiply by 1, Jocelyn?
Yes.
You're darn right I am. So what fancy form of 1 am I going to multiply that one by, Jocelyn? Exactly. 4 over 4. So this is going to turn into 5/20 plus 4/20, and the answer is 9/20. Okay? Alright. We got that as our answer. That's our answer. Multiplying and dividing is much easier. What's 2/3 times 1/5, Jocelyn?
That would be 2 over 15.
Very good, Jocelyn. 2/15. What's 2/3 divided by 1/5? Well, Missy Elliott is the one that came up with a little trick to how to do this. When you're dividing by a fraction, you put your thing down, flip it, and reverse it. Exactly. 10/3. You're on fire right now, Joss. Love it. Okay. All right. So you're going to need to be able to add, subtract, multiply, and divide fractions to be able to do these. Now, these are the identities that you're going to involve today. So I kind of already showed you these. I showed you these. Now I want to show you the most important one. Sine squared of u plus cosine squared of u equals 1. Tara, I want to teach this to you. You ready? Let's put any triangle. Uh-oh. Somebody changed that to apples. That was Marley. Little punk. Oh well. We're just going to draw them. Now, Tara, let's say I just have any general triangle where my angle is u. And if this is the point x comma y, then that's x, and this is y, and that's r. Do you recognize that? So, I want to prove that. Do you understand what this is saying? If you take the sine of u and you square it, and then you take the cosine of u and you square it, it's telling me the answer is always 1. That's like one of my favorite facts. And it's true. We could figure it out pretty easily. What is the sine of u, Tara? According to x, y, and r. What's opposite over hypotenuse? So this would be y over r squared, right? And what's the cosine of u? Very good. X over r squared. All right, now let's do our fraction stuff. So that is y squared over r squared plus x squared over r squared. Okay, now if we have the same denominator, we can combine them, right? So that is x squared plus y squared over r squared. However, look at your triangle and remember geometry. What is x squared plus y squared? It's hypotenuse squared. And what is our hypotenuse in this triangle? It's r. So we can take out x squared plus y squared and put in a what? A r squared. And what's r squared over r squared? It's 1. Okay? I guess to prove this to you guys furthermore, I'm going to do, check this out. I got to turn this thing on. It takes a while. Alright, check this out. How about parentheses, sine of 40 squared plus cosine of 40 squared. 1. Pick another number. Jocelyn, give me any number. Your favorite number.
19.
Oops. Sine of 19 squared plus cosine. Oops. Cosine of 19 squared. 1. No matter what angle we pick, it's always 1. Okay? So, that just proved this identity. So if there's one thing you learn from this that's very important, that I do love very much, is that sine squared plus cosine squared. Well, hold on. I got to explain something real quick. First, sine of theta squared, from here on out, we're going to call that sine squared of theta. It's just like a math thing. Okay? I don't love it, but that's how they're going to call it. So, sine squared theta plus cosine squared theta is 1. We just proved that. The other two are very easy to derive. All you got to do is, let's divide everything by sine squared theta. What's sine squared theta divided by sine squared theta? That's 1. What's cosine squared theta divided by sine squared theta? Cosine divided by sine. Let's go back to our trig identities that we just learned. Whoops. And let's see, cosine over sine. Cosine over sine, oh, that's cotangent. Awesome. So, cotangent squared theta. What's 1 divided by sine? That's secant squared of theta. So look, you see this thing right here? Secant squared is 1 plus cotangent squared. Over here, I think they write it as, there it is, secant squared is 1 plus tangent squared. Oh, no. Uh-oh, I messed something up. 1 over sine, I've been doing this my entire life. What's 1 over sine, Tara? It's cosecant squared, and that's why you should be teaching this class. But luckily, you're going to go on and do bigger and better things with your life. And finally, if we took sine squared theta plus cosine squared theta equals 1, and we divided it by cosine squared, you end up getting, let's see, sine over cosine, that's tangent squared theta plus 1 is secant squared theta. So those are the 3 primary Pythagorean identities. I only learn this one, and then I can always get to these 2 by simply dividing by sine squared or cosine squared. Okay? So what in the world are we doing? Great question. This is why I kind of hate this, because I don't even really know why this is a thing. Like, I don't even know really how it applies. It would be kind of like doing Sudoku. And that's why we're not going to take this super serious and freak out, but you guys are going to do the Math Excels and just practice this, because everyone else in high school has to do this. And at some point in college, it might end up mattering. But I can't tell you that I know when it does. All right, so how can we verify the following? Tangent squared minus sine squared equals tangent squared times sine squared. Well, the only thing it said to do is start with the more complicated side and work at it until it equals this. And this is, Mr. Lothrop and I battle about this. You cannot do something to both sides because we're verifying that this is true. So we're basically saying, is this true? The equal sign is poorly placed here, and that's why I hate this section. Don't put an equal sign here if they're not equal, but we're verifying it. So let's rewrite tangent as sine squared over cosine squared. And then, so that's our first thing. Now, let's get this to be sine squared over cosine squared. Remember what we learned about the fractions. Let's get a common denominator. So I'm going to multiply this by cosine squared theta over cosine squared theta. And we're going to get minus sine squared, cosine squared, theta, all over cosine squared theta. Now, why did I do that, you might ask? Exactly. You just got to try these things, and that's why some people really like them. It really is like a puzzle. It's a lot like a geometric proof in geometry. You gotta like think it through or try it, and it might fail. Then you gotta try something else. So what is this? Well, these have common denominators now. So now we can combine these fractions into one single fraction. So we'll do sine squared theta minus sine squared theta cosine squared theta all over cosine squared theta. Okay? Alright, now let's factor out a sine squared from the top. Sine squared theta times 1 minus cosine squared theta, aha, all over cosine squared theta. Now, if you remember, 1 minus cosine squared is a thing. Okay, let's see. Well, 1 minus cosine squared is sine squared. Can you see that? Since sine squared plus cosine squared equals 1, then sine squared is 1 minus cosine squared. And you're going to have to remember that. You're going to use that over and over and over again. So, I got to scroll down. Come on. Come on. So, what does that equal? That would be sine squared theta times sine squared theta over cosine squared theta. Okay. Oh, what's sine squared over cosine squared? That is tangent squared. And I think if I go back to the top, bam, look. I just got to write it in a different order, which is the same thing as tangent squared theta sine squared theta. So those are the kind of difficult problems you'll be doing. And that's why we're going to do it in a game show race style event. Okay, so what is a simplified form of the following trig expression? This is the last example. So they want you to write this in a different way. So let's write cosecant as 1 over sine. And let's write tangent as sine over cosine. Oh, nice. Well, those cancel, leaving you with 1 over cosine theta. But 1 over cosine theta is more commonly written as secant theta. So this is what you're doing. You're basically rewriting things in different ways, and that's the best setup I can give you. You got this goes along with your first Math Excel practice worksheet. Well, not a worksheet. Your first Math Excel homework, free practice. Boom!